Hi, my name is Latrinda Knighton, and on behalf of the Math Department, I want to welcome you to this brief presentation on mathematical language routines. In today's presentation, we're going to talk about what mathematical language routines are. We're also going to discuss why would you use those in the math classroom. I'll introduce you to the 8 routines. We'll also look at examples of what they look like. So first of all, I want to call your attention to the right side of the screen. If you take a look at the right side of the screen, you see a QR code and you see a bit.ly. And so that bit.ly is math, all lowercase, MLR, all caps. And so this bit.ly will allow you to access some additional resources to support your understanding of mathematical language routines. So as we are reminded of our district mission, let's also remind ourselves of the instructional focus for the Division of Academics, which is on planning, implementation, and assess and adjust. Our math department focus for this school year is on implementing consistent reasoning and problem-solving skills throughout our district. As you go through this presentation and you learn about those 8 mathematical language routines, you'll see how these routines can be used to not only support reasoning, but also support problem solving in your classroom. So what are mathematical language routines? A mathematical language routine is a structured but adaptable format for amplifying, assessing, and developing students' language. The routines emphasize uses of language that are meaningful and purposeful rather than just getting the answers. These routines can be adapted and incorporated across lessons in each unit to fit the mathematical work wherever there are productive opportunities to support students in using and improving their English and disciplinary language use. You see a reference here to Stanford University, which is the author of the mathematical language routines. You'll also have access to that resource through the bit.ly. And just for point of reference, a lot of people who are familiar with these routines will remember that initially they were introduced to support students who were learning English as a second language. But as all of us know, that math has a language all of its own. So anything we can do to uplift language in the math classroom will support all students. I also want to call your attention, you notice you see MLR in parentheses. A lot of times when people talk about mathematical language routines, they just use the acronym MLR. So as you see that throughout the presentation, do know that when you see that, we're referring to mathematical language routines. So why would we use these? Well, we know that students have to be able to read, write, listen, speak, and discuss in mathematics. So these routines are designed to support a variety of language-focused skill growth, from reinforcing mathematical terminology to scaffolding conversations to providing opportunities for students to deepen their conceptual understanding by describing their work. So the routines facilitate attention to student language in ways that support in the moment teacher, peer, and self-assessment. The feedback enabled by these routines will help students revise and refine not only the way they organize and communicate their own ideas, but also ask questions to clarify their understandings of others' ideas. So as some of you are looking for ways to uplift discourse in your classroom, incorporating these routines as a regular habit will really help you to facilitate that growth in your students. So on this screen, you see the 8 routines, and we will have an opportunity to unpack and look at each of these. But there are a couple of things I want to bring to your attention. 3 of those I've highlighted in red, 1, 3, and 4. These routines are typically used with students in grades 3 and above because students need to be able to independently read and write in order to execute those directions for those routines. Routine number 5 is typically used in grades 2 and above. And so the others span the entire K-12 the entire K-12 spectrum. So 2, 6, 7, and 8 can be used with all students. So routine 1, stronger and clearer each time. So the purpose of this routine is to provide a structured and interactive opportunity for students to revise and refine both their ideas and their verbal and written output. This routine also provides a purpose for student conversation through the use of a discussion-worthy and iteration-worthy prompt. So the main idea is to have students think and write individually about a question, use a structured pairing strategy to have multiple opportunities to refine and clarify their response through conversation, and then finally revise their original written response. Subsequent conversations and second drafts should naturally show evidence of incorporating or addressing new ideas and language. They should also show evidence of refinement in precision, communication, expression, examples, and reasoning about mathematical concepts. So here's an example of how you could use this routine in a classroom. This activity is called Convince Yourself a Friend, a Skeptic. So students create 3 iterations of a mathematical argument or justification for 3 different audiences. In the first draft, they explain or justify their argument in whatever way makes sense to them. In the second draft, they're encouraged to explain what they know and how they know it is true. Their explanations should include words, pictures, and numbers, and then they trade their written arguments with a peer who acts as a friend, giving feedback on those components. In the third draft, they're encouraged to explain why what they know is true by supporting their claims with evidence. Explanations should include words, pictures, numbers, and examples. They should include examples that look like they might not be true, but actually are. They should anticipate and address counter arguments. Now you see the relationship to the reasoning skills, right? So then students trade their written arguments with a peer who this time acts as a skeptic, giving feedback on these components. So you have to prove to the skeptic why your response is correct. Routine number 2 is collect and display. This is to capture a variety of students' oral words and phrases in a stable collective reference. The intent of this routine is to stabilize the varied and fleeting language in use during mathematical work in order for students' own output to become a reference in developing mathematical language. The teacher truly serves as the facilitator during collect and display. You're listening and you're scribing the language that students use, often during partner, small group, and sometimes whole class discussions, using any written words, diagrams, or pictures that students are using as they're working. The collective work can be organized, revoiced, or explicitly connected to other language in a display that all students can refer to, build on, or make connections with during future discussion or writing. So really throughout the course of a unit, or as you connect one unit to the next, teachers can reference this displayed language as a model. You can update it or revise it as student language changes and make those bridges to helping students to make those connections between their prior language and new disciplinary language. And so this is a great opportunity to provide feedback for students in a way that supports sense making while simultaneously increasing meta awareness of language. A little bit later, we're actually going to look at 4 different examples of collect and display because we're going to see how it actually progresses from elementary through high school. Routine 3, critique, correct, and clarify. The purpose of this routine is to give students a piece of mathematical writing that is not their own to analyze, reflect on, and develop. So the intent is to prompt student reflection with an incorrect, incomplete, or ambiguous written mathematical statement, and for students to improve upon the written work by correcting errors and clarifying meaning. Think about sometimes when our students have those reasoning questions where they have to look at maybe someone's incorrect, incomplete reasoning, and they have to decide which person is correct, which person isn't, and tell why. If you're looking to uplift this type of activity or this skill in your classroom, this might just be the routine for you to incorporate. As teachers, we can demonstrate how to effectively and respectfully critique the work of others with meta think alouds and pressing for details when necessary. So this is when we bring in what we know about helping our students understand how do you provide critiques? How do you talk to others about their work using respectful language in the classroom? This routine fortifies output and engages students in meta awareness. So, more than just error analysis, this routine purposely engages students in considering both the author's mathematical thinking as well as the features of their communication. So, a great example is using always, sometimes, never. And so a lot of us have used this structure before in the classroom. So you might use a graphic organizer for students to organize their work, or maybe just have a discussion. And so they're going to evaluate or critique whether mathematical statements are always, sometimes, or never true. So an example, a rectangle is a parallelogram, or a negative integer minus another negative integer equals a positive integer. These are all contexts that you can use this routine in. A lot of people like to use a graphic organizer to frame that work and then assess the reasoning process as students work toward evaluating and improving upon their responses. Routine number 4 is information gap. This routine, the purpose is to create a need for students to communicate. So, this routine allows teachers to facilitate meaningful interactions by positioning some students as holders of information that is needed by other students. So, the information is needed to accomplish a goal, maybe such as solving the problem, or maybe if they're playing a math problem solving game. With an information gap, students need to orally or visually share ideas and information in order to bridge a gap and accomplish something that they could not have done alone. Teachers should demonstrate how to ask for and share information, how to justify requests for information, and how to clarify and elaborate on information. This routine cultivates conversation. So let's look at an example. Some people like to use games in this context. So students might play a guessing game or a matching game in which they have a real reason to talk. So they need to work together to develop a strategy to win the game. And each student is provided with different information. One student has something in mind, and other students use their understanding of a mathematical concept to guess what it is. One of the examples here is guess my ratio. So one student identifies a ratio between two distinct features, objects in the room, or within a given set of objects, keeps the features, objects secret, and the other students try to figure out which features, objects are in the identified ratio. For those of you who work with younger students, I know one activity such as this I used to enjoy using with my students was a what am I guessing game using for having students identify geometric shapes or objects. So students would have a card that provided some information about the characteristics or qualities of a two-dimensional or three-dimensional figure. And so based on the characteristics given, their partner had to guess which figure was being identified. And so you could make it a little bit simpler for younger children. You could add more details to make it a little bit more detailed and a little more challenging for older students. But it's that info gap where students are guessing, someone has all the information, and so others have to use that information that's given to help them figure out the answer. And students love to play games, so this is a great one to incorporate in the classroom as well. Number 5 co-craft questions and problems. So obviously we can see this is once again one of those activities that involve students working together. The purpose is to allow students to become familiar with the context before feeling pressure to produce answers, to create space for students to produce the language of mathematical questions themselves, and to provide opportunities for students to analyze how different mathematical forms and symbols can represent different situations. Through this routine, students are able to use conversation skills to generate, choose, meaning argue for the best one, and improve questions and situations, as well as develop meta awareness of the language used in mathematical questions and problems. So here's an example of this routine, and it's called co-craft problems. So students work in pairs, and so they create new problems. So they get together, co-create problems similar to a given task. Then they solve their own problems before trading them with another pair. Once they exchange the problems, students solve the other pair's problems. They check the solutions and methods with the pair who created each problem. So they go back and double check the work with the actual authors of the problem. And if you've taught for quite some time, this is where sometimes students maybe are a little bit eager. They might create a problem and maybe they left some information out, or maybe they had something that was ambiguous. Having that partner exchange is a good checks and balances for them to see what possibly is missing. And the last part is just the teacher can provide topic support. So maybe you give them a context or give them some topics. If you're working on addition, subtraction problem types, you might tell them what type of problem you need them to create. Multiplication, division problem types, you might tell them which one of those problem types you want them to create a problem based on. And then they can choose their own context to illustrate their problem, or they can, work as a class to brainstorm topics. But I like the idea of making it very focused, making it in the moment, and making it related to what you're working on with your students. Routine number 6 is 3 reads, and I know that there's a lot of familiarity with this routine. I've seen lots of teachers in our district use this in their classrooms. The purpose of this routine is to ensure that students know what they're being asked to do, create opportunities for students to reflect on the ways mathematical questions are presented, and equip students with tools used to negotiate meaning. So this routine is a great routine to support reading comprehension, sense making, and meta awareness of mathematical language. It also supports negotiating information in a text with a partner in mathematical conversation. So this routine is just as it said. Students are supporting and reading a situation or a problem 3 times, but each time they read it, there's a very specific focus. So the first read is they read the situation with the goal of just comprehending the text. What is happening here? What is this problem about? Without even looking at the numbers. In the second read, they read it with the goal of analyzing the language used to present the mathematical structure. The third read is to read the situation in order to brainstorm possible solution methods. So a lot of you have seen the numberless word problems. These work well as a 3-read problem because students read the problem with all the numbers taken out. Then you put the numbers in, and they start to think a little bit more. And then the last part is you actually put in the question that they're being asked. So if you're using numberless word problems in your classroom, that's a great way to do the 3-read mathematical language routine. This routine works well in conjunction with mathematical language routine 5, in which the question stem is tentatively withheld in order to focus on the comprehension of what is happening in the text. This is a great routine to use to help your students actually unpack and dissect the context of the problems they're trying to solve. Routine number 7, compare and connect. The purpose of this routine is to foster students' meta awareness as they identify, compare, and contrast different mathematical approaches and representations. This routine leverages the powerful mix of disciplinary representations available in mathematics as a resource for language development. In this routine, students make sense of mathematical strategies other than their own by relating and connecting other approaches to their own. Students should be prompted to reflect on and linguistically respond to these comparisons. For example, exploring why or when one might do or say something a certain way, identifying and explaining correspondences between different mathematical representations or methods, or wondering how a certain concept compares or connects to other concepts. Be sure to demonstrate asking questions that students can ask each other rather than asking questions to test understanding. Use think alouds to demonstrate the trial and error or fits and starts of sense making, similar to the way teachers think aloud to demonstrate reading comprehension. This routine supports metacognition and metalinguistic awareness and also supports constructive conversations. A great example of this routine is the problem solving prompt, which one doesn't belong. I know a lot of you use these maybe to open a lesson or introduce a topic to your students. Many of you have probably even used a popular website or the actual book that originated this actual problem solving tool. Pairs of students are provided with sets of 4 numbers, equations, expressions, graphs, or geometric figures. They must decide together how to group the sets so that 3 of the items fit within a category they have created and 1 does not. Both partners should be prepared to explain to a different group how they agreed on a category and justify which item did not fit. I know sometimes I've used which one doesn't belong as a opening task, maybe as an opening routine before students move to concept development as it related to the context of what we were working on. And so it's a great tool to really get kids talking and really have them analyzing and looking at the things that are presented here and being able to justify using mathematics the response that you chose. The last routine, number 8, is discussion supports. So the purpose of this routine is to support rich and inclusive discussions about mathematical ideas, representations, contexts, and strategies. The examples provided in this routine are instructional moves that can be combined and used together with any of the other routines. They include multimodal strategies for helping students make sense of complex language, ideas, and classroom communication. The examples can be used to invite and incentivize more student participation, conversation, and meta awareness of language. Eventually, as teachers continue to demonstrate, students should begin using these strategies themselves to prompt each other to engage more deeply in discussions. Think about some of the actual stems that some of you use for conversation stems. That's an example of a discussion support. These are things used to help facilitate that discussion. Numbered heads together is a popular Kagan strategy that many of us have used in our classroom to support students with engagement, to support discourse. This is a good one for a discussion support because, as you know, with this particular task, you have students count off so that they are in groups. You pose a question, problem, task to the group that students have to provide an explanation. And then, of course, then that group puts heads together. And so they come up with their explanation or their justification for their problem or their part of the problem. And so usually I know a lot of us like to have kids even use like chart paper so they create some type of display that supports their work. Or students can do something in a journal, whatever works best for your classroom. Then most importantly comes that part where they get to report. So they get to talk about and explain, what they've done. So as the teacher, some people might call a random number from 1 to 4 if you had your kids count off from 1 to 4. And so the person or the student who has the number that's called, they become the reporter for their group. And so they get that opportunity to explain the next step of the problem. Or if a previous reporter has presented, they can agree and or disagree and to tell why and justify their reasoning to the rest of the group. And so this is where they're actually just looking at the process, where they're looking at all the steps that they've done to solve the problem or the task or the situation that's been presented to them. And so again, numbered heads together, everyone has to pay attention during that time because I'm randomly going to call a number. So I need to be ready so that if my number is called, I'm able to explain the work of my group or explain the problem. So everyone's accountable in this type of activity. So as I promised, I wanted to go back to collect and display, and we wanted to look at 4 different examples. So looking at lower elementary, upper elementary, middle school, and Algebra 1. So what I'm going to do is show you a sample task or activity that students would use, grade level appropriate, and then talk about how the teacher would use the collect and display math language routine to support students in this task. So a first grade task, the one that's presented here, is comparing story problems. So what's happening here is in this particular lesson, students are interpreting representations of put together, take apart problems with unknowns in different positions. So they're expected to be able to discuss how each equation matches the story problem and where in the equation you see the answer to the question. So they start out by working with a partner, and then eventually partners are put together to form a small group of 6 students. But what's happening where the collect and display component comes around is as the students are working, the teacher is monitoring. So the teacher is circulating among the partners, the teacher is circulating when the partners join together and become a small group. And you are literally listening to the things that the students are saying, but also collecting that language, meaning you're making you're making anecdotal notes. So you might be typing those notes on your tablet, typing those notes just on your Chromebook. You might be noting them, like really handwriting them in a notepad. But eventually, you're going to actually take that language and display it for everyone to see. So you might put it on chart paper for very young students, or you might actually type it so that you're displaying it on your active board when you have that group discussion. And so in this type of activity, some of the language that the teacher is listening for is listening to hear what type of vocabulary, math vocabulary students are using, such as total, equation, not known, and making note of those things. Are students using any type of visuals or pictures to support their understanding? So making note of those things. And so when you debrief with the entire group, that's when students have a display, because some of the language that's happening in other groups might help some students to have a better understanding of what is happening, or it may help some students make more sense of what's happening with those different problem types and how they actually can interpret those representations to solve those problems. So this is a wonderful opportunity to really practice your facilitating skills, where you are really being that listener and that person who monitors and watches as students are working. When we move to an upper elementary example, this is one from 4th grade. And as you can see, this is one where students are doing some things in the geometry domain. And so basically for this activity, students are doing Do You See What I See? And it's a similar type activity. I remember engaging in things like this as a child myself, and then also using these with students in my classroom. So students are given images. And so when they're partnered with their partner, they have to use descriptive terminology to describe the image. And so the partner has to interpret those descriptions to recreate that image. So we're really listening and collecting language that's related to that geometry terminology. So some of the things that a teacher might listen for might be line, point, straight, corner, quadrilateral, triangle, rhombus, vertical, horizontal, middle, top, bottom, left, right. Some of those types of things that students should be using that type of vocabulary, that type of language. So you're listening, collecting again, displaying on a chart paper or your active board, somewhere where you can use it to enrich the group discussion at the end. Also, you might also be collecting some of the visuals that students are using. So based on what someone said, the language they gave to one particular image, you might actually make a quick sketch of the different interpretations that you saw other students using, and then use that in the group discussion so students could see, how did students arrive at this image? How did the language that their partner used lead them to think that this might be the image they were describing? So really unpacking and enriching the class discussion and student understanding by having them have a snapshot into what was taking place in those other groups. As we move to a middle school example, this is one from 7th grade. And so in this activity, students are actually using strategies they've learned in the past to solve problems involving fractional percentages. And so one of the neat things is this is set in the context of dining at a restaurant. And so students are seeing, where this student or friend has had a meal in a restaurant. And so you see the restaurant bill, and then you've got a couple scenarios about what they're going to do based on, what percentage of the subtotal is the sales tax, after the tax, what's the total, and what's the percentage of the subtotal, what percentage of the subtotal is the total. And then thinking about, how did you actually figure out what percent was used to comprise the tip? And so on the screen, you see a couple parts of the problem. So you see part one and you see part two, and you see the things that students are using as they're solving this. So while students are working with partners, one of the things that's going to happen is that the teacher is going to, again, monitor, circulate, and as you are monitoring and listening to the students talk about their approaches to this problem, for how would they calculate sales tax, how would they do the tip, how would they find the subtotal and the total cost, you're going to write down some of those common or important phrases that you hear students saying to describe their work, making sure that you're listening for, are they using some of those strategies that have been introduced in the past? Are they talking about unit rate? They're talking about the equation. Did anyone use a double number line? What about a table? And as you unpack that discussion with students at the end, you're going to have a visual display so students can see what other students were talking about. They can also hopefully make a connection, real life connection, to some of the mathematical terminologies that they've been using as part of this unit. So as you notice, this is really about the teacher being that facilitator. The teacher's observing and making lots of notes. So our last example is from Algebra 1. And so this activity has a prompt where students start by seeing like a video about oranges return. And so as you can see here, a couple of directions for things that students are going to have to do to complete this task. There's reference specifically to what does the linear model estimate for the weight of the box of oranges for each of the numbers of oranges. So they've got a table to fill out, and then they've got some more tasks that are related to this. So as you can see, this is a big problem-solving task. So students might do this over the context of more than one day. They also have an opportunity to work with a partner. And so the purpose of this lesson is really to informally assess the fit of a function by plotting and analyzing residuals. So the term residual is actually introduced to students during the context of this lesson. And so as students are working on this task, the work of this lesson connects to previous work because students analyze bivariate data by creating scatter plots and fitting linear functions to the data. So as students are working with their partners and they're completing this task, they're using the video prompt and using all the tools that they've been asked to do. They've been prompted using some of the language they're familiar with. As the teacher, and you're walking around and you are collecting information, you are listening to hear how students are connecting the language from prior lessons to the new learning that's being introduced here. You're making note of those things again, using the display that works best for you. If it's using your active board or just journaling something down in print and then later transferring it somewhere where all students can see it. And most importantly, it's really important for this task, is to make sure that you are displaying at the end some of those things that students have talked about, some of the things that you've seen them doing, some of the things that you might display for a lesson such as this is words and phrases such as difference between actual data and estimates. Estimate is greater or less than actual data. Linear estimate is close to actual data. And so students are beginning to think about, how do I use language to communicate what I'm doing mathematically in these tasks? How does it connect to the work that we're doing? And how can I use what I'm learning from my classmates to uplift or to enrich my thinking and my understanding of this task? And really to help them, because this is where you're introducing them to a new vocabulary term in the course of this lesson. How can they use that work that they did, the discussions they had, to actually have a good understanding of what that means? So as you can see in Collect and Display, this is a wonderful opportunity to practice being the person who monitors, visiting your groups, finding out what students are doing, and using student language to uplift what's taking place in the classroom. So we definitely want to thank you for joining us for this presentation on mathematical language routines. And hopefully you've noticed that there's some common threads throughout all of these routines. Even though the purpose is to uplift student language, to help students to really make sense of the mathematics that they're learning, notice that each of these routines provides you with an opportunity not only to have students engaging in discourse, but also having students working together. So when you're thinking about, planning structures in your classroom, thinking about planning activities that will help you to better align to the compass rubric for your observation, these are great routines to bring into your classroom to really help support that understanding and those structures, and make sure that you are actually providing students with a wide range of opportunities to really think about the mathematics, talk about it, use language to describe it, and really promote those reasoning and problem-solving skills as they're going through their mathematics understanding and lessons. As always, if you have any questions or you want additional support with this topic, on this screen, you see the names of everyone with the math department, and you have our email addresses. Once again, that bit.ly is there, so you can use it to access the additional resources that we have to support mathematical language routines.